All right, we're back, and this is where we're going to kind of pick up where we left off. We were talking about pointers, and I promise you this is going to tie in. We're talking about default values and null. We'll recap this stuff at the end. We've been initializing instance variables in our constructors, but technically you can't initialize them the moment they are declared. Right here we see a class header. I see these things. I know they're instance variables because they have an access modifier. We're also inside the body of the class. That's probably actually the most important thing, right? These variables are being declared in the body of the class. I'm not in a constructor. I'm in a class body. And you see I'm giving them values right away. In the case of this integer, I'm giving a value of 7 right away. In the case of this string, I'm giving a value of bar right away. You can do this. Let me show you. I got IntelliJ pulled up. I got this little test class. We've already plugged in a main method. I'm going to make a separate class. Right click SRC, make a new Java class called whatever, my class. Okay, I'm in the body of the class. I'm going to create integer x, and what's different is not only am I going to declare it, I'm going to initialize it. I'm going to go ahead and plug in a constructor to really kind of hone in on the point. I am not going to touch it in the constructor, right? X is declared and initialized here. I'm not even going to touch it in the constructor. In order for us to see this value, however, I'll probably want a getter. I'm going to insert one using Alt Insert. Select my getter and select that guy right there. Let's flip back over to our tester, where I'm going to create an instance of that class, right? I'm going to create my class. We'll create my object. And that is a new my class. Right, this is going to call the default noargs constructor here, right? And there's nothing happening in it. But if I take my object and ask what is the value of x, we'll get back a 7. Okay? Something that's kind of important to note, like what if you do this and then do this, let's say, right? What if I declared initialize it, but then in the constructor I try to assign it a value? Which value do you think it's going to take on? I'm going to flip back to my program. I'm going to run it, right? And you'll see that we get a 21. So what that tells me is that this is executing. This is actually happening, right? We are declaring and initializing x to 7, but then the constructor is overriding the value, okay? So best practices tell us we should use the constructor to initialize our instance variables, right? I shouldn't be doing this. We haven't done this before, and I really shouldn't. I wish I had a good reason, like a good, solid, logical reason as to why this isn't a good idea. The best I got is that you could possibly be like initializing in 2 different spots, and that's kind of confusing, right? Like when I see the 7 up here, I'm like, x is going to be 7, and then there's a constructor where x is a completely different value. So I think that is the real downside to it. But to be fair, I don't have a super good reason other than maybe best practices says we should use the constructor to do that. That's what the constructor is for. What if you do neither? What if I don't give it a value here and I don't give it a value here? Does our program just break? I don't really see a syntax error. IntelliJ seems to be pretty happy. Why don't I try running my program and let's see what we get. What do you think we're going to get? I get a 0. In Java, instance variables have to have a value. Period. They have to. They have to have a value. If you don't initialize an instance variable upon declaration or in the constructor, right? If you do neither, the instance variable will assume a default value based on its data type. Here is all of our primitive data types, right? We see byte, short, int, long, all zeros. Float and double 0.0 because these represent floating point numbers. Boolean has a default value of false, and I told you a long time ago to think about this as 0, so that makes sense to me. And then lastly, char, this is the Unicode for 0. This is 0 the character. Okay, so don't let this like super confuse you. It's 0 the character. Or it's 0 on the Unicode bitmap. I guess that's probably more accurate. Okay, there is this note here that I just kind of glossed over. We're talking about instance variables here, not local variables, right? Local variables are the ones that appear in methods or they're parameters in methods, right? This is the old school thing where if I had to take x, if I declare integer x here, and then I try to print off x, it gets mad. This is a syntax error. So what we're talking about are instance variables. Instance variables assume a default value, not local variables. More importantly, object instance variables will assume a default value of null if they are not assigned a value. Right, so I'm going to add to this. This is effectively all of our data types. Right, we got those 8 primitive data types, then we got object, which basically covers everything else. And we're saying that all objects assume a default value of null if you don't give them a value, if you don't initialize them. Null, sometimes referred to as the null object, the null value, or null type, is a simple concept that has a somewhat obscure implementation. Null is not an object, but acts like an object in some scenarios. For instance, null is stored in memory. Basically, whenever your program executes, there is a spot in memory that's set aside that represents null. It represents nothing for all objects. Any object variable can be assigned null, right? Since this takes up a spot in memory, think back to our pointers. This takes up a spot in memory. I can tell string variables to point to that spot, right? Pointers. I can tell this string str to reference null. Okay, so this is applying to objects. There's a note here, null cannot be assigned to primitive data types, but you can tell all object variables to point to that thing, right? Visually, they look something like this. I am declaring a string variable called str, and then I'm going to use the assignment operator to tell it to point to null. And as you can probably imagine, at least hopefully imagine, you can have all these different variables also point to null. You can actually have several variables referencing null in the same way we saw with our pointers lesson, that you can have objects of the same type point basically at the same object, right? I think I created, what do we make, mouse? We could have multiple mouse variables pointing at the same mouse. You can have multiple object variables all referencing null, effectively meaning they don't have anything. There's nothing there. Null is not an object, but acts like an object in some scenarios. Null can be passed as an argument to any method that takes an object explicit parameter. Okay, explicit parameter, remember that's the one in the parentheses over here. So what I'm saying is that this is not a syntax error. I have my string with a value of test. I'm going to take that string and see, does it equal null? Syntactically, this works. Okay. Now, what you're going to see mostly on the AP exam is that you'll see methods, and they will say something along the lines of, this is going to be in like the Java doc. It'll say that this parameter is not null. What that means is you don't have to check for it. Okay, that's what you're going to encounter most often. So this is really not something you have to worry about. But the only reason I'm pointing out is because null is not an object, but here it's kind of acting like an object, right? It's something that can be passed as a parameter. That's a little odd. However, null will never be an implicit parameter. If you have your string that's set to null, and you try to do this, you're going to get what's called a null pointer exception. Now, I imagine some of you have actually seen this error before, right? I know a lot of people maybe saw it in Locker if they were working with a string array. What this means is you didn't initialize the implicit parameter. The word choice here is very direct, almost said explicit. Null cannot be an implicit parameter. You get a null pointer exception if the implicit parameter is null. A null pointer exception occurs when a variable that references null attempts to invoke or call a method. Okay? So if you were to basically tell me, I'm getting a null pointer exception, I take a look at your code, I'm going to see what line it's on. I'm going to see what on that line is an implicit parameter. And that's going to be your problem. That's going to be your null value. Okay. Typically, the solution to this problem is to initialize it, to initialize the variable in your constructor. So let me kind of just show you an example here. I'm back in our little nonsensical class. I'm going to come in here and I'm going to say private string str. I haven't assigned it a value here. I haven't assigned it a value here. That means it's going to assume a default value, which is what? I'll insert a getter for that. I'm going to flip back to my test. Right, so we're bringing in an object variable. I'm not initializing it either at the point of declaration or in the constructor, and I want to see what the value is. Okay, I'm back in my class. I'm going to simplify this a little bit. I still am creating an instance of my class called my object. I want to take my object and see what that string inside is. And we use an SOP to kind of see that. Okay, it's going to assume the default value, and the default value for all objects is null. Okay, let's say I try to use this string somewhere. I don't know, maybe I am trying to write a toString, and I want to say return str along with the value that's in str. Oh, that's just going to tack on null. Has to be an implicit parameter. Public void my method. I'm going to take str and why don't we return str char at 0, and we'll make this a char. This is kind of just a nonsensical method. I'd like you to notice. We'll get rid of the toString because it's pointless. I like you to notice there's no syntax errors here, right? IntelliJ is happy. My issue here is a random hyphen. Don't know where that came from, but I'm going to call that method, right? I'm going to say my object dot my method. Still no syntax errors, right? All it's going to do is return the character at index 0, and hopefully you're alarmed because there's no string here, right? We just saw that str is going to assume a default value of null, right? That is different from a string with a length of 0. This is an empty string. It's still a string. It's still a string object. It just has a length of 0. Null, on the other hand, is nothing. It's not even an object. Okay, so let's take a look at the error that we actually got. And what I'd like you to recognize is that this occurred at runtime, right? There's no red squigglies in my code. IntelliJ is happy. I have no syntax errors. This exception, like all exceptions, is a runtime error, null pointer exception. My string is assuming a default value of null. So whenever this method is invoked, whenever it is called, here on this line, actually if I even click this, no, if I click this guy, it's going to jump to this line. And I know that a null pointer exception occurs whenever the implicit parameter is null. The only implicit parameter on this line is str. str is null. The fix for that is to give str a value, right? I don't know. Even if we do this, right, if we set it to an empty string, we're going to get effectively an index out of bounds because there is no index 0. If I do a space, we're going to get a space back, and that'll fix everything. But what I want you to recognize is the fix for the null pointer exception is to initialize the thing that is null. Give it a value. Tell it to point to something other than null. Like all exceptions, null pointer exception is a runtime error. As we saw, this error did not pop up until I actually executed my program. Okay, let's recap the stuff that we've learned. The following method call will return a number in what number range? This is some Math.random stuff. I believe we got like a quiz coming up, which is why this recap is a little bit bigger. Well, Math.random is going to give you something like 0.0 on the low end up to 1.0, but not 1.0 itself. So effectively, we're taking our 10 and multiplying it by the lowest number possible, 0.0. Well, it's going to give us 0.0 on the low end. On the other end, I'm going to multiply that 1.0 times this 10, and that's going to give me almost 10, but not quite. So your number range looks something like this. Right? I'm multiplying the 10 by the lowest number that was possible out of this. I'm multiplying the 10 by the highest number that's possible out of this, and that's how we get this number range. Once we bring casting into it, things are a little bit different. The following method call will return a number in what number range? One. What happened here? Okay, think about precedence. What has the highest precedence? This thing right here, I could be wrong, it could be the cast, but regardless if Math.random is happening first or the cast is happening first, we're getting 0 out of this expression. We're taking that 0, multiplying it times 6, getting 0. I didn't add 1 to that. So I'm getting 1 every single time. Okay, let's put it in parentheses. Now what does our number range look like? The cast actually helps make it a little bit easier, because then we can bring in our rules of thumb. That is, multiplying by 20 gives me number of possibilities. What is my lowest number? It's still 0. Right? So far it's 0. But it's 0 up through 19 inclusive. There's 20 numbers in that range, right? 0, 1, 2, 3, all the way up to 19. So I'm getting 0 through 19 inclusive on both ends, but we're taking 5 and adding it to the top and bottom of that, right? I'll take the 0 and add 5, so we're shifting the bottom end up, but I'm also going to shift the top end of that up as well. I'll take the 19, add 5, giving me 24. Occasionally, the blank will delete any unreferenced objects from memory. This is going to be the Java garbage collector. What is printed by the following? Here we got a mouse object, we got another mouse object, and I want to know, does Mickey equal Remy? Well, they're both going through the noargs constructor here, so you would think that, yeah, they're going to end up with the same values. Of course they're the same, except they're not. Why? Well, ultimately what the equals relational operator is doing when you use it to compare objects is you're asking, are they pointing at the same thing? Very simply put, no. We're using the new operator, which means that Mickey is going to point at a brand new mouse object. Remy is going to point at a brand new mouse object. So these are actually two distinct mouse objects. Now they are going to have the same state because they're both using the noargs constructor and should thus have the same value in theory, unless this is doing like a random thing. But they are not literally the same object. These two variables are pointing at two distinct objects. Okay, what if I do this? What if I say Mickey is a new mouse, and then I take Remy and tell it to point at the same thing Mickey is pointing at? Well, yeah, if I use this relational operator to then check the pointers, these two are in fact pointing at the same object. What is the purpose of the equals method? Of an equals method, I should say. Well, we saw what the downfall of using this is, right? It doesn't check for equality, it's actually checking for pointers. That's the purpose of the equals method, is to see, are the two objects the same? That is, do they have the same state? Determine if two objects have the same state, and keep in mind when we're talking about state, we're talking about instance variables. Are all the instance variables the same? What is printed by the following code segment? Here I have a main method header. We say that student Billy is null, and I want to know what is Billy. Oh, we're going to get a null value out of that. Okay. We're seeing that student, this is an object, is pointing at null. Cool. I create double X. Keep in mind, context matters. We're in the main method. Maybe I didn't quite show this one. If this was subtle, let's back it up here. I just realized what my question was asking there. Okay. So when we were on this slide, we were saying instance variables must have a value. Local variables do not assume a default value. I should clarify that. Let's jump over to our little tester class. I'm going to come at you with some type of object, string, str is equal. Actually, let's just declare it. Oh, I guess I was manually setting it. Let's make sure this works. Yeah, okay. Yeah, we right. str has not, local variables do not assume a default value. Okay, so it's correct. Ignore what I just did. All right, so Billy is null here. We have double X. Okay, we're inside of a main method. This is a local variable. It will not assume a default value, which means X is going to give us an error. And this is copy and pasted from the slide before. Local variables do not assume a default value. A blank occurs when a variable that references null attempts to invoke a method or call a method. When the implicit parameter in a method call is null, what happens? That is a null pointer exception. And it's also the end of our slides. See you in the next one.